I can. I feel terrible. She looks just like Max. I mean, he looks nothing. Do you see me in that kid at all? Besides the hair. I mean, his bachelor ski picture, he's got his pass at bachelor, and the hair is exploding. I'm like, well, there it is. But you look at his face, you look at her face. I mean, yeah. I will. I'm sorry. I should get more of it. So, here's Bertha. We bought Bertha. Do we know what Bertha is? I call her Bertha. But do we know Bertha's a girl?
No, it's Bird.
It could be. It could be Bird. Very nice. It might be Bird, not Bertha. So, what we're going to do is we're going to have flock number 1. Flock number 1 is just one bird. Let's analyze what happens if we buy one bird. Serenity, we're finally answering your question. Where do the probability columns come from? I'm going to get to it right now. So let's build the left column first. The left column first. X equals number of girls. This is what I care about. This is what I care about if I want to raise chickens for eggs. I'm interested in how many girls I get. I don't want boys if I want eggs. If I want fertilized eggs, I want a boy. But if I want eggs, they're going to lay eggs with or without a boy around. If I buy one bird, how many girls can I get?
One.
I could get one, or I could get none, right? I could get the 10% rooster. So those are my random variables if I purchase one bird. Either 0 or 1 girls. What is the chance of each of those events happening?
10 and 90?
That's what the guy told me at the store, right? He said there's a 10% chance that I've got a boy and a 90% chance that I've got a girl. Fair enough?
Mm-hmm.
Can you find the average of that distribution?
Oh, for jeez.
Say yes.
Yes?
Because you can.
That's what I meant.
I just wasn't used to hearing it like that. It's a strange way of saying yes. Can we find the average of this?
Yes.
Of course you can. Of course you can. The average number of girls, because that's what you'd be finding. If you average this distribution, you'd be finding the average number of girls would be 0 times 0.1, which is 0, and 1 times 0.9, which is 0.9. So on average, you would get 0.9 of a girl. To which we hear chuckles. I can't envision 0.9. Is that like missing a tail? But think about what it means. Think about what it means to average 9/10 of a girl. Say it that way, 9/10. What does that mean?
You're likely to have a girl.
Well, you're likely to have a girl, sure. But what does the average of 0.9 or 9/10 mean?
9 out of 10 times.
9 out of 10 times you're getting a girl. That's what 0.9 means as probability, right? So this is a fairly straightforward, kind of boring example, because it's kind of like, duh, yeah, that's what he told you at the store. So yeah, you're going to average 0.9 girls, because he told you 90% of the time you get a girl. Okay, fair enough, fair enough. Let's make it more interesting. Let's add, who do we add next? I forget. We add Nancy next. So now we've bought Bertha and we've bought Nancy. Let's build the distribution around the number of girls I could expect from a flock that contains 2 birds. And remember, both of these birds have an uncertainty to them. Every time Max grabs a bird, he's flipping a coin. It's not 50-50. It's
90-10.
90-10, thanks Stace. It's 90-10. It's not 50-50. Everything we're going to be talking about over the next couple of days with the binomial distribution is about flipping coins. But it's not always 50-50. Sometimes the coins are weighted, 90-10. The germination, the pumpkins, 60-40. That was a coin flip too. Is that seed going to germinate? I don't know. Flip it. Is that die going to be a 5 in Chuckala? I don't know. Either is or it isn't. These are all binomially kind of examples. All right, so flock number 2. Number 2. 2 birds. Let's build it. Now, Serena, this finally gets into the actual, we have to do some calculations here. Number of girls. Number of girls. And then the chance of those numbers. We'll get to that secondary. Okay, Max brings home the box. Happy Meal box. 2 little peeps peeping inside of it. Could be 0.
Could be 1.
Could be 1.
Could be 2.
Could be 2. That's it. These are discrete random variables. That's the number of girls I could have in that box. What's the most likely outcome, do you think?
2.
2? How likely? What is the chance of getting 2 girls?
Less than 90.
Say why? Thank you, Nick. Why? Less than 90. Why? We're treated as independent, yes.
So-
Did you hear what he said? Less than 90.
So 0.81,
Why 0.81?
because you've got a 90% chance with each one of them, and you multiply that together.
Why do you multiply them?
Because that's what you told us to do for
Oh,
the dice.
No, this is beautiful. This was your last project.
Functional counting principle.
It is.
Yes.
Think about this, friends. Think about this. You've got a 90% chance of the first one being a girl, and you've got a 90% chance of the second one being a girl. As goofily annoying as that last project was, the one underlying theme of the entire project was when you hear the word "and," you multiply. Just like the first project, when you hear the word "or," you add. That was, as annoying as those projects were, granted, I know they were annoying to you, that was the overriding principle. Or means to add, and means to multiply. If you want the first one to be a girl and the second one to be a girl, the chance of both of them then for being a girl is 0.9 times 0.9 or 0.81. Thank you. That's perfect. That's perfect. Good. I love that has to be less than 0.9. That's such a wonderfully intuitive way of approaching this. The more girls we buy, the chance of them all being girls has to go down. Because every time Max goes in that box, he's flipping a coin. And it doesn't have to come up girl. The only way it would stay the same is if there was a 100% chance of one of those birds being a girl. And there's never that. There's never that because it's always a coin flip. That was such a wonderfully intuitive way of connecting it. Good. What's the chance? Grab one of the other ones. 0 or 1, your choice, really.
0 is 0.1 times 0.1.
I love it, isn't it now? Listen to Christina. Can we do the 0 the same way? We want the first one to be a boy, and we want the second one to be a boy, which means the chance of both of them being a boy
That's 0.01.
is 0.01% chance. Pretty unlikely. Pretty unlikely. So right now, the most likely case, roughly 4 and 5 times, we're going to get 2 girls. If we just buy 2, they're both going to be girls. Now, what's the chance of 1?
Is it 0.9 times 0.1?
Now what did it have to be? Because if we're getting 1, we're getting a girl and a boy, yes?
Yeah.
Now check this. I'm going to put 0.9 times 0.1, which equals what? 0.09, yes? Now if we stop with that though, what's wrong?
We don't get the 100%.
That's a problem. Check this out. That's 0.09, yes?
Yeah.
If you sum this up,
It's too much.
it's 91%. We are short 9%. Now, I've told you we can be off with rounding errors. You can't be off that much. That's way too far off. So what's the... Now, so Patrick has just figured out, assuming we can live with this and this, this needs to be 0.18. Yes.
Yeah.
Why?
Because it has to equal 1.
Because it has to equal 1, but think of the chickens. I want you to make a connection to the context of the problem. When we said 0.9 and 0.1, what did we assume?
90%.
Who's this? Who's the 0.9? Pick a chicken.
That's
Bertha or Nancy? Who's this? So you're making Bertha be the girl
Yeah.
and Nancy being the boy.
Oh, does that mean the one that's a boy?
Oh, but it could be a
Couldn't-
boy. Oh, it could be a boy or a girl. Okay.
So Heidi, you're 100% correct. Yes, Tiffany. So I'm going to say it a different way. Either Bertha's the girl and Nancy's the boy,
or
Yes,
or means
It means add.
Bertha's the boy
And Nancy's the
and
girl.
Nancy's the girl. And what do we get now? There's our 18% we were missing.
Oh, for gosh sake.
You see? Isn't that beautiful? Well, I call it beautiful. You just go, I buy it now. Heidi, go!
Okay, I understood myself, but I don't quite understand. Okay, so what we're looking at there is the first set is a chance of one of them being
That chicken being a girl and that
Right.
chicken being a boy. But that chicken could be the girl and that one could be the boy. There's 2 ways for one of them to be a girl. You have to account for all those ways in the distribution. This ties directly back to your question, Madeline, about Chuck-a-Luck and the number of 5s. The 0 and the 3 are very easy. The 1 and the 2 are trickier because you have to account for the ones that are and the ones that aren't.
Right.
Heidi, does that make sense?
It does now.
It gets way more interesting when the flocks get larger with 3 and 4 birds, which we won't get to until next time, and that's okay. But this is, Serena, this is why I didn't do this at first. Because if you're trying to understand how to do an average of a distribution and trying to figure that out too, it's ridiculous. It's too much at once. Speaking of averages, how many girls will I average in a flock of 2? What's the average number of girls that I'm going to have if I get a flock of 2? Well, it won't be a percent, it'll be a number of birds. Okay. Now, what Nick just gave me, the most likely outcome is 81%.
2.
But on average, it's got to be less than 2. Now here's why. Think about that. You can do this 1 bar stats if you want to. You can totally do it 1 bar stats. Go ahead, do it 1 bar stats real quick. Knock out 1 bar stats, and then I want to walk through it piece by piece because I want to address both what Madeline and Nick just said because they're both very, very important. So run 1 bar stats, and this is why I'm saying this is practice for next Wednesday because you're actually running 1 bar stats, getting results. Son of a... It's okay. It's all right. It's all right. It's still recording. Look at that.
What about moving that thing over
What I'm going to
here?
do is I'm going to go to Lowe's and get a damn bolt for this thing. Yeah, but...
Wait, take the thing off. Maybe it's a little metal thing.
It is a little metal thing. We're good. I got a 3-year warranty. It's good. I'm going to put it here for a few moments because we're almost done class anyway. And that will be... That's actually pointed-ish.
1.8?
I got 1.8? 1.8? 1.8? Okay. Now, first of all, there's a couple ways you can view that 1.8. First of all, if the average for 1 bird was 0.9, that means every time you buy a bird, you're getting 0.9 of a girl.
Right.
So if you buy 2, you should get 1.8 girls on average because you're doubling the flock. That's one thing. Why is it not just 2? Well, remember the componentry of the average. 81% of the time, you're getting 2 birds. That's 1.62 girls contributed in that situation. 1.62 girls. 18% of the time, you're getting 1 girl. So that's 0.18 of a girl in those situations. And you're getting no girls 1% of the time, which doesn't contribute anything to the average. So if you add up all those components, 0.18 plus 1.62, you get 1.8. So the entire distribution is contributing chunks to that average, just like it was in Chuck-a-Luck. But it's pure addition because we're not taking anything away. Like we're not betting on these guys yet. We will bet soon. Is that fair? That's a lot. That's heavy. Wait till we get to 3 and 4. It's even more fun.
These 2.
But we'll wait for that for Monday. Yes.
1.62.
So let's take a pause.
This.
Take a pause.
Your average.
I'll talk about Monday. Monday, you got a project due, yes? Simulation, super counting. No homework, just the project. No homework, just a project. So knock that bad boy out. And then your exams are Wednesday. Yes. You got very quiet all of a sudden. In class and out of class, yes. I don't see, well, could push the out of class back a few days if you need to. Let's do that. Let's make it do if you want, like on Friday. If you need a couple extra days to do the out of class. I don't think you will.
But if we do,
I don't think you will.
Okay.
And I don't want to wait it too far because I don't want it to get so far back that it's then like, what am I doing again? Like this was 3 weeks ago. So if you need a couple more days, that's fine. Just get it done. But Project Monday, I'll have the quiz posted on for Wednesday for you. Again, it's optional, so don't do it if you don't want to. And then we'll get back into the chickens on Monday. All right? All righty. And I will get a better